Think about a standard rigid block, 6 flat, square faces meeting at perfect 90-degree right angles. We can even force this strict geometry into the food we eat. This specially cultivated Japanese watermelon is a biological cube, constrained by those exact same perpendicular corners. Suppose you take a heavy blade, striking this object with a single, perfectly straight cut to divide it into 2 identical pieces. There are obvious ways to do this straight down the middle, but imagine we apply a strict geometric condition. The flat surface exposed by that single slice must be a perfect, regular hexagon. This comparison shows exactly why that sounds contradictory. A cube is built entirely out of 90-degree corners. A regular hexagon is defined by 120-degree internal angles. The math completely clashes. Resolving this paradox requires us to drop our standard assumptions about flat surfaces and physically change how we orient the object. Instead of looking flat against a square wall, let's tilt the shape. Try staring directly down at a corner, a vertex, so it overlaps the opposite vertex pointing toward the floor. From this vantage point, a structural equator appears. 6 connected edges trace a zigzagging path around the center, and none touch the top or bottom points. Identifying these 6 central boundaries reveals a secondary path through the cube that isn't immediately obvious when looking at its square faces. This schematic plots the exact center point of each of those 6 middle edges. The letters mark the precise mathematical midpoints. By drawing lines between these 6 specific coordinates, a single unified flat plane materializes directly through the interior volume of the box. This rendering illustrates the physical separation. As the 2 newly formed chunks slide apart along that specific angle, the resulting intersection is a flawless hexagon. This abstract geometry dictates physical reality. Looking at the freshly cut watermelon, tracing the blue outline across those midpoints proves the shape is intact. Rigorous mathematical logic, no matter how abstract the initial orientation, maps perfectly onto the physical constraints of reality. Let's inspect the interior surface of this cut. Radiating lines naturally divide the hexagonal face into smaller, identical building blocks, 6 perfect equilateral triangles. This diagram demonstrates an inscribed circle grazing the exact midpoint of all 6 sides. Point O marks the exact center. Because this hexagon is the perfect midplane, this circle represents the equator of a sphere sitting perfectly inside the cube. A solid cube functions as a housing for these internal, radiating symmetries, which only become visible once we slice through its right angles. With the structure finally split, we are left with 2 unusual 3D chunks. We need to verify if this diagonal slicing operation truly yielded identical pieces. To prove this mathematically, we unfold both pieces into flat 2D blueprints called geometric nets. This image places the 2 unwrapped nets side by side. Every dotted central hexagon, adjoining square, and triangle mirrors the other exactly, proving they are mathematical duplicates. We took a standard, highly rigid shape and managed to extract a multifaceted geometric sequence right out of its center. Simply shifting our perspective allows us to uncover beautiful, perfect symmetry, hiding inside even the most ordinary, rigid structures in our world.